Hey guys, it's Bastian. I'm the CEO and co-founder of PeakAce, and we are a Berlin-based full-service performance marketing agency. Thanks very much for having me. We're gonna do a deep dive into Google's core web vitals, and yeah, so everything and anything around web performance really is kind of what's on the agenda for today. Before we get into it, I kind of have a bit of a, well, let's say a bit of a confession to make, and that is that I am really, really impatient. So for me, there's nothing worse than having to wait for anything to load. It just literally drives me somewhat insane. And also, and I think you probably by now think that I have lost my mind, but I found GDPR actually pretty cool. Well, to be fair, not the entirety of GDPR, but so there's one example that I want to share, and I think then it gives you a bit of context. But there's the publication in the US, which is called the USA Today, and obviously they're serving clients not only in the States but also in Europe, or the European Union in the wider sense. And when GDPR came into place, what they had to do obviously is they had to kind of become compliant for their European readership. And what they did is they kind of built a site that's essentially entirely stripped down. And on the right-hand side, you can see some comparison of web performance metrics, basically showing that, well, if you look at render times, but also load times in general, that this site is actually significantly faster, right? So it took roughly 19 seconds for the US side, or still does, only 0.9 for the European side, and they essentially eliminated all the JavaScript, which was mainly tracking and banners, reduced therefore a whole amount of requests, etc., etc. So I hope you can see where I'm coming from. These sites really now all of a sudden are fun to use, and I think we as marketers are somewhat not, well, let's say we kind of played our part in the fact that websites somewhat became slow. Quick recap on users' expectations. This is the study taken from Nielsen. We will essentially lose half of our people because they will leave a website if it doesn't fully load within 3 seconds. So expectations are quite clear. And for me, really, performance is about user experience, because kind of this fast loading time really plays an important role in the overall user experience, right? So this is nothing new, just a very quick recap. Page speed already is a ranking factor, right? But what most people tend to forget is that performance is somewhat a relative concept. So, a site might be fast for one user, but very slow for another one, because, well, it could be on a slow network with a low-end device, right? Or two sites may finish loading at the exact same time, yet one somewhat may seem to load faster, maybe due to a progressive enhancement. Or, a site might appear to kind of somewhat load quicker, but then actually responds slowly, so it just feels like clunky, right? You tap on something and nothing happens, which is also really frustrating. Which is why Google introduced something that's called the Core Web Vitals. And important to note here is this is the 2020 set, so there might be changes coming in the future. Essentially, this consists of 3 different metrics. Largest contentful pane, first input delay, and then cumulative layout shift, CLS in short. They also give you somewhat reference numbers, so kind of the areas, or let's say ranges, that you need to aim for. How to get to those numbers and how to measure them, I think for those that are a bit familiar with the topic, you already can recognize the logo. The answer is Google's Lighthouse, and the reason is, so Lighthouse brings a whole bunch of different types of metrics. Some can be seen here on the left-hand side. Could be those that I mentioned, but can also be things like blocking times and a lot of other things. Historically, we have been measuring just the load event. However, that is because that's a well-defined event, but it does not necessarily correspond with anything a user really cares about. So we have this shift to now use multiple metrics. If you're not familiar with Lighthouse, very quick as an overview, and I'm kind of happy to share the slides. So if you're watching this, feel free to email us hi@pa.ag. We'd be happy to share the slides. So essentially, Chrome brings Lighthouse by default, so you can just right-click on the page, click Inspect Element, so you get into Dev Console or Dev Tools, and then there's a tab that says Perform an Audit, and then you can run it, and that's about it. There's also a Chrome extension that makes it a bit easier accessible, or if you have to scale things, if you don't need the interface, you can of course run it also as a CLI, so in the command line interface, based on a node module. So 3 different ways of doing it. As I said, Control-Shift-I, that's for Windows, obviously. Find the Lighthouse tab. There's some settings that you can go through, should be going through. Definitely make sure that the performance category is checked. Select the device type, mobile, desktop. Quick reminder here, if you're not familiar with it, running web performance audits should be done in incognito modus. So just make sure that you have a fresh, clean incognito open, because plugins and whatnot, and I think we as SEOs tend to have a lot of them kind of running on the local machine. Well, that has an impact on performance, so the numbers might be flawed. What you'll be getting is something that looks a bit like this. Basically, this is a Lighthouse report overview. Right-hand side on the top, you have various options, as well as kind of you can import and stuff like that. Left-hand side, you get different types of numbers. Again, we care about the one that says performance, and then you have a detailed kind of measurement breakdown using kind of the most common metrics. We touched on that as well as, which is quite helpful, a film strip view, so you can kind of basically browse the site and then understand when which type of kind of event or performance metric actually kind of became available, right? So yeah, and then you can drill down, of course. So it gives you an opportunity section, it gives you diagnostic section, and then you can basically go into the different types of recommendations here. So it tells me in this case to kind of eliminate render blocking resource. That it gives me also timing, so the time that I can actually save if I do it properly. And then you can zoom in for a whole lot more info. So it kind of gives you also which kind of files or URLs are affecting this, etc., etc. Keep in mind that metrics are measured in one of two ways. That's very important. And you can find them in DevTools, performance, and then the timings. But there's lab data, which is essentially using tools to somewhat simulate page load. This is kind of in a controlled environment. So that's the one way to do it. The second, and that's kind of the real world data, is what we call field data. So it's on real users actually loading and interacting with the page. So that takes into consideration, of course, different types of browsers or devices in general, different types of connections, different types of like features of the mobile phones being used and whatnot. So this is really like the real world data. You can track pane timings if you want to in your Google Analytics. There's something that's called the Performance Observer. Better to be using the Web Vitals JavaScript library, because if you use the Performance Observer, you need to really understand what type of event is going to happen and how to execute that, etc. So it can become a bit, let's say, stressful sometimes to deal with the different types of events in JavaScript. So the library kind of has you covered there. And then, of course, what you can do is you can output that in analytics, similar to what you're kind of probably familiar with. So this is kind of a custom view where we collect performance metrics, those three that I've mentioned before. And then you have like an overview of how does your average LCP, for example, look like, etc. So that's kind of the theory. I would say we get into it. Let's start with kind of trying to answer what impacts what, right? Because I think before we can really go into it, it's important to understand what type of optimization potentially has an impact on which metric, so that you know, once you have run your audits, that you know where to start. For core Web Vitals, I try to provide a solid overview. It's a bit hard because there's sometimes overlap, right? But if you look at LCP, so the largest contentful paint, oftentimes we're talking about server response times, blocking scripts, and JavaScript, CSS, generally resource loading, as well as kind of client-side rendering issues. So to optimize for that, again, you need to work on a server, you need to work on your CDN, caching, as well as compression. Critical rendering path is something that we need to talk about. Blocking times in general, when you load certain things that are necessary for painting. So again, JavaScript, but also fonts, etc. Images is a huge topic. And then there's a bunch of like loading strategies where you can preload components, etc. First input delay is mainly, to be honest, around JavaScript. It can be third-party JavaScript. It can be your own JavaScript that's, for example, is a very huge file, and therefore then it just kind of keeps the main thread busy. So there's that. It's a lot of JavaScript things, splitting JavaScript, breaking up long tasks, eliminate all like polyfills that you potentially had used for kind of backwards compatibility of all browsers, etc. So this is around FID, and then shift. When we talk about CLS, it's often and almost always something that has to do with dimensions. So if you're kind of injecting banners and you haven't reserved let's say, a spot for that, then of course you have a high CLS, which is what you don't want. So essentially images without dimensions, adds, embeds, iframes, again, without dimensions, but also fonts. So we're going to talk about fonts later a bit as well. And then kind of the optimization, I think, is relatively straightforward, mainly about size attributes, adding them, reserving required spaces, and then you have oftentimes almost kind of eliminated that entirely. So the concept I want to start with is the critical rendering path. And this is essentially kind of the code and resource that you require to render the initial view of a web page, right? So if you look at it conceptually, what we have is we have a section of a page that's critical, we call the initial view, and there's stuff, well, obviously then, which is not critical. So this is kind of the below the fold. If you think about it, of course, that also varies depending on the screen size, on the resolution, and the device type. Technically, this works like this. So what we have, or what we need, or what the browser needs, is the so-called Css Object Model. So essentially, it is kind of a map you can think of, where we have all the CSS styles that are found on a web page. It's a bit similar to the DOM, but it's for CSS, not for HTML, right? So if you think about, for example, you have a headline, and that headline has a certain font size, then this is what would be one map entry, or a background color of something else, or a font color of something else. So this is kind of the map that we're talking about, essentially understanding style sheets for HTML. Web browsers would use this CSS object model to actually render a page. So essentially, when they kind of go through the HTML and build the DOM, they see that there are CSS calls in there, one or multiple ones. And if it's an external CSS, the browser obviously needs to wait for the download to happen. And then it can combine the DOM with the CSS object model to create what's called the render tree. And only then the browser can actually display something on the web page. Google doesn't make, and that's quite interesting, I think, a single CSS GET request, because requesting external CSS is actually more expensive than inlining everything. And the developers now would say, well, oh Jesus, if you inline everything, it's extremely hard to maintain. It's extremely hard to kind of work with that, etc. I feel your pain. Actually, I learned, but that's a long time ago. I learned software development almost 20 years ago. So yes, I feel your pain. I like to use a tool called Critical, which is essentially it builds you a CSS that is required for the critical section of your page, and then a second one, so it's essentially splitting it up in in the second one where there's all the styles that are not needed straight away, and you can even do that with the tool in various desktop or mobile phone resolutions. So you could probably take your, let's say, top 5 resolutions that kind of serve 95% of your user base. And if you put it together, it's really cool. So if what you do is basically you inline only your critical CSS, right? So just the stuff that you need for above the fold. Then you would load the non-critical CSS asynchronously using the rel equals preload directive. Then once the file has been loaded, because, well, it can take a bit, but it doesn't matter because, well, we will only show it later anyways, then you apply the CSS once that had happened. And then you need a fallback, obviously, for non-JavaScript requests. So we use the good old NoScript. Plus, we implement what's called a polyfill for some of the, well, let's say old browsers, but they do support JavaScript, or when they do support JavaScript. So this is the fastest way of actually getting CSS delivered if you don't want to go full crazy on inlining everything. There is something that's really brand new, which I'm super excited about, which is called the content visibility property for CSS. So essentially, it enables the user agent to skip an element's rendering work, and including layouting and painting, which is the stuff that's the most expensive and takes most time. So until that is needed, and that makes, if you think about it conceptually, it's a bit like lazy loading for images, but not that you can only do it for images now. You could do it for entire paragraphs or divs or whatever. So super exciting. This is something that I think we will be hearing a lot more about in the next month. A big topic that I also want to address quickly is images or image optimization. Because, well, first and foremost, where do you find it? And I'll tell you why it's important. So one of the things that you could see in your Lighthouse, for example, is a recommendation to kind of properly size images, for example. And there's a whole bunch of more image recommendations. But roughly 60% of all web traffic is being made up of images, and that's a lot, right? So the average site gets roughly almost 1 megabyte of images per single URL. And as you can see from the chart here, taken from HTTP archive, this is constantly growing, which is crazy. So, basic optimization should be done for everything and anything. I'm a big fan of Tiny PNG, Tiny JPEG. There's a whole bunch of others that can do image optimization work. Whatever you feel like, but make sure that you do it. The reason why I like this one is it has an API, it has a WordPress integration, and it even has an integration into Photoshop. So, strategically, what you could do is you could even like start the process very early on when your design team actually starts out building things and they export it. Like let them already kind of optimize, and then you don't have to do it afterwards, because that's what we see often in audits, that people just forget about it. There's no kind of automated solution when someone uploads a new image and then, well, you had your work done and then you need to kind of start again. Of course, compression, if you want to do it yourself and don't want to use on a kind of external service, image min is great. There's also image magic. There's a whole bunch of different solutions that you can actually use for that. At least make sure that you use something. Webp is kind of Google's alternative to like all the old formats, JPEGs, PNGs, GIFs. Like they are all very, very old. It is effectively 30% smaller than JPEGs, 80% smaller than PNGs. It works in Chrome, Opera, and Android, so it kind of is there in terms of adoption. But I've been talking about this for like almost 3 years now. So it took quite a while. You can use it kind of as on-the-fly replacement if you want. So you could just like swap them out server side with a rewrite for like on Nginx or Apache. You can of course also just do it on the front end. So if you use like the picture element, it allows you to specify different types. You can see it here for our logo, right? So 2.5 kilobyte as a WebP versus over 7 as a PNG. So yeah, there's some good savings in there. There's a company called Best Buy in the US, just as a quick example here. It's basically done with a service called Cloudinary. Cloudinary does what I just told you, just add scale, because that's somewhat like an image CDN provider. So they would always pick like the best format for you. So in this case, it's WebP, but it can also be, again, AVIF, which is something that I'm really excited about. Kind of again, new format that just shipped with Chrome 85 and the latest Firefox. And that, even in comparison to WebP, is again significantly smaller, which is kind of a collaboration between Google, Cisco, but also already Netflix and others are using it because they kind of manage the same quality, but are really, again, significantly smaller. Last thing about imagery, make sure that you also generate responsive images. Like one image for all the screen resolutions doesn't really work. It's just either too much overhead or too bad in terms of quality. So make sure that you do that. If you have no clue how to start with it, responsivebreakpoints.com is a great help. So you can put an image there and it generates you like the responsive variant. You can download and deploy. It even gives you the code with it. Really cool. Or again, Cloudinary can do that for you. The other thing that you see a lot, and this is the other big lever in terms of images, is something that says defer off-screen images. Essentially, what we talk about here is lazy loading. In the past, Google and others had been recommending a loader called Lazy Sizes, which again, like what it does is basically when you have an image that's not straight away in your viewport, it would essentially go and kind of load it only when you kind of scroll to it and it comes into the viewport. I think the concept is quite well known by now. There is an easier way, which is really great to do that, which is called native lazy loading. So essentially what you now just need to do is you need to add loading equals lazy to your images or to your iframes, which is, by the way, very exciting. So you can now finally make images and videos fast. Google supports it already. So yeah, if you're not using it for whatever reasons, make sure you do. Last comment on imagery, always specify dimensions, because that will prevent any CLS. It's super important if you have images that you specify width and height attributes, not only for images, but also for iframes, etc. The other big thing I want to talk about quickly is custom web fonts. So custom web fonts essentially are a performance killer if they're not done right. What you're looking for in Lighthouse is essentially something like this that says, ensure that the text remains visible during web font load. That would indicate that you're probably depending on some kind of third-party font, really. Over 70% of all sites are actually doing that. Again, over 100 kilobyte of additional data, oftentimes 4 to 5 additional requests. So that just takes a lot of time. This was kind of the traditional way to do it. You would just use kind of an external CSS, from like say googleapis.com or whatever. Of course, again, if you think about it conceptually, that would mean that the browser first needs to download it and it needs to be processed. So it just takes time. You could say, well, then I do it asynchronously, right? Because then I don't need to wait for it, which is great. But what happens is then that you oftentimes experience either void or FOUT, kind of either unstyled or invisible text, which is kind of causing this this irritating flickering in the load process, which is super annoying, which you don't want, of course. One way to fight it is using a tool called Font Style Matcher. So Font Style Matcher would basically allow you to find a default font on your machine or on the kind of user's machine, and then style the custom font similarly to the default font by letter spacing, line heights, etc. At least, well, I'm not saying it's a perfect solution, but at least it makes it somewhat equal and reduces kind of this thing jumping around situation, which you certainly don't want. There is, however, because the browser vendors obviously understand that this is an issue, right? And this has been an issue for quite a while. They introduced what's called the font display strategies using CSS. And essentially, I think this one visualizes this quite nicely. You can go and make fonts non-blocking. By default, as I said, it would be blocking. But what you can go is you can say, well, either you just reduce the blocking period, or you could just go and say, well, you can download it in the background, and only for the second page view, you would be using, let's say, the custom font. But for the first page view, where it should be also really, really fast, you use the system default, and then you just do a swap, for example. If you're using Google Fonts, this has been introduced a bit later, but like finally there now as well. You can also use the same methodology by when you load this kind of from external service, in this case from Google. You can just append the parameter display equals swap, and you would have the same behavior as I just described for CSS. And then I want to also quickly talk about some of the more server-side-ish things, time to first byte, a bit of CDN situations, and more. Again, what you would be seeing in Lighthouse, so this is for time to first byte, right? Reduce your server response times, of course. I see a lot of discussion around, like, should I even worry about TTFB anymore because it's not part of the core Web Vitals? Well, yes, you should, because if your server is already slow, how can you then have other metrics being fast? Like if the server, which is the first thing that needs to respond, is slow, not going to happen, right? So here's some orientation in terms of what you should be aiming for. And then if we talk about server-side already and CDNs, then there's also various hints in Lighthouse. This is, for example, saying reduce the impact of third-party code that is hosted on the Google CDN. If you work globally, CDNs can be really great help. I'm a huge fan of a website called CDNperf to find kind of the one that suits you best, because it is really depending on where you are and which regions you are predominantly serving. Not every CDN is working the same way in every geographic location. So don't just blindly pick one. Let's say if you serve the Asian region, that's a very different game as to serving North America. If you do both, then even more so you need to think about it conceptually. If you want a CDN recommendation, though, and this is more from the kind of my geeky side of things, it's Cloudflare. Cloudflare has the concept called Cloudflare Workers, or the service called Cloudflare Workers, and a lot of other really cool things, by the way. They're doing a lot of amazing things on the web performance side. But anyways, check those out. They're super powerful. Essentially, they're kind of a serverless JavaScript, which is really, really cool. You can also preload certain key requests. So the idea is, if you know that something will be needed, then you can use kind of browser spare time early on and make sure that you get it done. So this is a waterfall diagram for a website that's actually relying on a CSS that's sitting on a subdomain. So what happens, of course, if you need the CSS, there needs to be a DNS lookup, and in this case, it's really, really slow. What we ended up doing is we ended up adding DNS prefetching in the head. So essentially, what then happens is the DNS lookup from like the IP to the domain name will be done already kind of almost immediately when the browser hits the statement. And so when the request happens, it's already done. So you don't need to wait for it. Since we're all on HTTPS connections by now, you should combine it. So DNS prefetch and preconnect, because preconnect, so the second statement essentially does also do like the SSL like negotiation, as well as like the certificate handshake. So that's all off the desk, and you can kind of request the resource almost immediately. You can do that also for, let's say, hero images. So if that, if you have a massive image that you need to be visible straight away when the browser hits the statement, then you could in your head already kind of add a preload, because that, that would then kind of especially prioritize critical imagery to be kind of, loaded over the other existing images on a page. This now has also kind of landed just recently in Lighthouse, so the recommendation is now there. It has been a thing for a while already, but yeah, they now actively recommending this to everyone. One thing that I also want to address is performance budgets. So essentially, it's not done with a couple of those optimizations. It's more about creating awareness, and not only awareness but also limitations beyond just the one team, and really make sure that people kind of commit to hard numbers. So essentially, what they introduced in Lighthouse a while ago is called Light Wallet. So what you can do is you could say, like, well, my website is only allowed to have 300 kilobytes of scripts, or it always needs to load in a certain time frame. So let's say like the first meaningful pane needs to happen within like 2 seconds, for example. And you could even say, well, I have a tolerance of like 500 milliseconds, but if it's over, then it's over. You can do that for different types of connections, so Wi-Fi or just 3G or whatever. And if you do not know where to start, there's a really cool kind of tiny tool. It's called the Performance Budget Calculator. So it's somewhat allowing you to synchronize spending with your goals. So it gives a bit of a starting point and generates like this budget file, which is a JSON. So I think it's really important to kind of embrace those performance budgets and then really learn to live with them, or within them, actually, not only with them. And also make sure that the testing that you do and the budgets that you set are realistic, because like there's weak or weaker phones where you can just not go entirely crazy. To finish off, a couple of tool recommendations, kind of besides the regular Lighthouse that you all are familiar with. Of course, there is GSC, so Google Search Console, which now has a Core Web Vitals report, both for desktop and mobile. So this is like the real world data I mentioned earlier from the Chrome UX report. So this is something that you can work with. There's a Chrome Web Vitals extension, which is really helpful. So this is great. There's another Chrome extension that's called the Core SERP Vitals. So that gives you pane timings basically in the search results. So this is quite cool if you kind of want the numbers to be straight away visible. If you need to scale Lighthouse, because you need to test multiple URLs at once or want to, then there's a free tool called BatchSpeed, batchspeed.com, where you can just throw in a bunch of URLs. You get those nice overviews in comparison to each other, for example, or just at scale. Really helpful. If you do not want to, well, let's say if you want to run it on your own machine, but not as a SaaS, like with BatchSpeed, then Lighthouse Parade, again, link is in the slides, is kind of a crawler, a Node.js command line tool that crawls through an entire domain and then compiles a report based on the Lighthouse performance data for every single page. And then we have what's called the Crux report, where you can kind of do report comparison at a glance, which is essentially allowing you to easily compare desktop versus phone results. So this is quite helpful if you need to kind of figure out certain things and want to compare them next to each other. Super helpful. One thing that I also enjoy a lot using is kind of the layout shift GIF generator. So if you need to visualize like shift scoring and things that are moving around, so this tool helps to kind of easily identify problematic shifts in the viewport on desktop as well as on mobile. And then it gives you like a GIF image that you can kind of embed. SpeedCurve is my kind of all-you-need web performance monitoring tool. It's probably by far the most comprehensive one on the market. It's really cool, but it's somewhat a bit more on the enterprise side of things. I think what's really important is that web performance is not really just a project you're just not done once you're done, but it's kind of an ongoing situation, an ongoing process. So make sure that you're not like just think, well, it's finished and I'm done, because things are somewhat moving around. And with that, yeah, you made it through. Thank you very much for dialing in questions. Happy to answer them. Shoot us an email. Also happy to share the slides. hi@pa.ag. And with that, I am switching off. Bye, y'all.